Experiment 18 deals with hydrocarbons. You'll look at chemical properties, boiling points, and you'll have an unknown that you try to identify by using chemical properties and boiling points. Let's look at part A. Chemical properties means reactions, and you'll use 3 reactions to decide if you've got an alkane, alkene, or an aromatic as your hydrocarbon unknown. Well, let's look first at reaction with bromine. Bromine, when it's in solution, is a bright red color. Well, not bright red, but red, we'll say. And alkenes have that carbon-carbon double bond. They're pretty reactive, and they react with bromine to give a product that uses up the bromine, so the red color disappears. We get a colorless solution. Alkanes and aromatics, they don't have the carbon-carbon double bond that gives alkenes its reactivity, and so those particular substances stay a red color. In part B, you'll use the reaction with potassium permanganate to differentiate alkenes from alkanes and aromatics. Won't separate alkanes and aromatics, but it'll tell you if you've got an alkene or not, because potassium permanganate reacts with that carbon-carbon double bond. You get a brown coloration. Alkanes and aromatics, they stay the purple color of the potassium permanganate. Let's look at part C. When hydrocarbons are burned, we find that they give different amounts of smoke as one of the products. Alkanes burn very cleanly, and they give little or no smoke. Alkenes, a little more smoke, and aromatics give lots of smoke. And so this is the test that will help you decide if you've got an alkane or an aromatic. We had 2 chemical tests for alkenes. Now you'll be able to differentiate between alkanes and aromatics. Let's look at part D. In part D, you'll be using boiling points to help you identify your unknown hydrocarbon. The very first thing you'd want to do is to classify your unknown as an alkane, alkene, or an aromatic, because you have those three possibilities, and you have a table with possible alkanes, some possible alkenes, and some possible aromatics. So classifying your unknown based on those chemical tests that you just did will tell you which table you're operating in. And then you'll use boiling point. Say that you've identified your unknown as an alkene, then you'll use boiling points to say which alkene it is. You'll be constructing a graph, and on the vertical axis, you'll plot measured boiling points, and down here on the horizontal axis, the normal boiling point. Normal means the boiling point at sea level, and we know that altitude affects boiling points, and thermometers have some inherent errors in them too. So you'll determine boiling points of 3 standard substances, and when you do, you'll be getting a measured boiling point. The literature, the lab experiment itself, will tell you what the normal boiling point is. And so for that first experiment, you'll go up with a hypothetical line. You'll come across from your measured boiling point, and where those 2 hypothetical lines intersect, you'll put an X. And you'll do the same thing for the second material, and the third. You'll have 3 X's, you'll draw a line, and that'll give you the graph then will help you as you take the boiling point of your unknown. Because now you'll get a measured boiling point for your unknown. Taking a hypothetical line, you'll come across until you hit the graph, come down, and that would give you the normal boiling point of your unknown. With that data then, knowing the class of substance that your unknown is in and having its normal boiling point, you'll be able to identify the unknown.